All right. In this video, we're gonna focus on progressive wave, types of progressive wave, and progressive wave equation. Okay, and solve some exam possible question on progressive wave. Okay. Now let's start, please. Let's get the definition of progressive wave. A progressive wave is a wave that transfers energy from one point to another. A progressive wave is a wave that transfers energy from one point to another in a medium without any net transport of matter. Okay, so in this wave, there is no transportation of matter. Okay, no transportation of matter. Please take it. So all waves transfer energy, but not all waves do not transfer matter. Okay, so in progressive wave, energy is transferred, but matter is not transferred. Please take it. Energy is transferred, but matter is not transferred. Okay, that's what makes it to be a progressive wave. So now let's look into the types of progressive wave. Okay, now types of progressive wave. All right, we have two major types of progressive wave, and we are going to get their definition. All right, the first one here is said to be transverse wave. Now let's get the definition of transverse wave. Okay, that's right. When the propagation of the wave particle is perpendicular to the direction of the wave. When the propagation of the wave particle is perpendicular to the direction of the wave, this is called transverse. That means whenever the wave particles is perpendicular to the direction of the wave. So whenever the wave particle is perpendicular to the direction of the wave, at that point we call it transverse wave. Okay, so now let's take the next one here. We call this longitudinal wave. Okay, now whenever the wave particle is in parallel, or whenever the wave particle is along the direction of the wave, we call this type of wave longitudinal wave. Please take note. So the word here, the short way here to define this is along. You put A here. That is when the wave particle is along the direction of the wave direction. That's whenever the wave particle is along the wave direction, is called longitudinal wave. When the, please take note, wave particles is along the direction, along the direction of the wave. when the wave particles is along the direction of the wave, we call that longitudinal wave. Please take note. So class, let's take the progressive wave parameters here. That is the parameters to calculate whenever we are asked to find, or whenever we are calculating for progressive wave. Okay, let's take progressive wave parameters. Okay, so go ahead please. Progressive wave parameters. So what are the progressive wave parameters here? Let's consider the first one here. A, we have amplitude. Please take note. This is the first wave parameter here. A, amplitude. So now let's know what amplitude is. Please take note. So that amplitude is the maximum displacement. Amplitude is the maximum displacement. Okay, can be denoted by A or small letter a. Please take note. Amplitude is the maximum displacement. It can be denoted by A or small letter a. Please take note. So now let's take the next one here, B, the next progressive wave parameter. Is said to be wave length. Said to be wave length. Please take note. Okay, now let's take the definition of wavelength here. Is right. Distance between two successive crests or trough is called wavelength. Distance between two successive crests or trough is called wavelength. So it means that the distance in a successive crest or the distance in a successive trough is known as wavelength. So we use this letter here, lambda, to denote wavelength. We use the letter lambda to denote wavelength. Please take note. The next here is said to be wave velocity. That is the last one here under progressive wave parameter. It's said to be wave velocity. Wave velocity. Okay, let's define what wave velocity is, please. This right. Wave velocity can be defined as wavelength per unit period. Wave velocity can be defined as wavelength per unit period. That is V sub W sub W is equal to lambda over T. This is a formula for wave velocity. Okay, now this can also be, this formula here can also be related in terms of frequency. Please take note. This formula here can also be related in terms of frequency. Relating wave velocity in terms of frequency, we have this to be VW is equal to lambda times 1 over T. Please take note. Also, remember, if I have something like this in mathematics, 2 over 3. Okay, sorry for this. If I have something like this in mathematics, if I have 2 over 3 is the same as 2 times 1 over 3. Please take note. This here, please take note. This here and this is the same. Please take note. But there's a definition. We know that 1 over T is the same as frequency. Then whenever I see 1 over T is the same as frequency, that means our VW will be equal to lambda F. Please take note. Okay, so we can either take this as wave velocity, the formula for wave velocity, or we can either take this as the formula for wave velocity. Okay, now let's take an example here before we conclude on progressive wave. Let's take an example here before we conclude on progressive wave. Before we take an example here, okay, please hit the subscribe button to get the full video on progressive wave. Hit the subscribe button to get the full video on progressive wave.